let's see how this rule is applied to example. So in the textbook, there is some example, figure 3, figure 3.6. So this is how derive for the given sentence to the past tree. I think we already practiced in last week, right? So this is the one sentence. So we can draw past tree. So assignment is variable and equal an expression, right? And the variable can be a. The expression means variable plus variable. Variable can be a, variable can be. So therefore, in syntax, by syntax rule, this is correct. So now we can apply the semantic rules. Okay. 그래서 우리가 여기 이렇게 저번 시간에 했던 거 신텍스 룰은 BNF 폼을 VM 한번 연습을 하셨으면은 파서 추리를 이렇게 그릴 수가 있습니다. 네. Okay. Now we apply the semantic rules. So first, let's say if you see the rule, maybe the rule number 4. Number 4 is the semantic rule variable dot actual type is defined by lookup variable string. Okay. So so we know the so that means the variable dot actual type. So it has a property actual type. Actual type is determined by a. By this variable, we can define the actual type, right, of this variable. And by this assignment, assignment rule, rule number 4. If you see page down, page up. Yeah, rule number 1. When we apply this syntax rule, we have another symmetric rule. EXPR, the expected type is set by variable dot actual type. So therefore, when you apply this assignment, EXPR dot expected type is set by variable dot sorry. Yes. You can just denote by the arrow. 그래서 우리가 아까 이렇게 derive 할 때 요 semantic rule에 의해서 요거 EXPR의 expected type은 variable actual type로 결정된다. 이렇게 화살표를 일단 그려 놓을게요. Yeah, for this rule, the A type can define variables actual type, right? Actual, let's say actual type AT. Similarly, it determines its actual type. Yeah. Right. And then when we derive EXPR plus, so when we derive this rule, this is rule for what? 우리가 요 더하기 할 때 어떤 룰이죠? 더하기 할 때는 요리죠. Rule number 2, right? We have two rules. One is a semantic rule. The second is a predicate function, predicate rule. So by semantic rule, the actual. So we apply this rule. Okay? So by this, so it has actual type. So this rule, this attribute is determined by considering this one and this one. Okay. 그래서 우리가 사실 이제 이렇게 파스트리에서부터 이 어트리뷰트가 어떻게 결정되는 플로우는 뭐 이렇게 딱 단방향도 아니고 그 룰을 따라서 이런 식으로 결정이 된다라는 그림을 그릴 수가 있습니다. Okay. So here we have another check some predicate. Here we have to check a predicate. So now let's say some example. Let's say A is integer and B is integer. Let's assume this condition. 그래서 우리가 만약에 A는 인테저고 B도 인테저다. 그럼 이게 어떻게 grammatically 맞느냐라는 것은 so we have to check the predicate whether it is true or not. So if A is integer, for example, B is integer, then this variable actual type becomes integer, right? And this is also becomes integer. Because this is integer, this EXPR, the expected type should be integer, right? And this is integer, B is also integer. Because of these two are integer, so actual type, EXPR, that actual type follows the semantic rules of number two. So if we follow this rule, then this actual type becomes integer. If we check the predicate, integer is incorrect. This is true. So if we apply this predicate, 어디였지? It should be same, right? So this is integer equal integer. So therefore true. Therefore this is correct in semantics. 그러니까 이런 식으로 만약에 이렇게 주어졌다, 그럼 이제 애트리뷰트를 이렇게 거꾸로 이렇게 이 화살표를 따라서 결정이 됩니다. 그 룰에 따라서. 그렇게 하면 이 프레디켓 지금 예전에 하나밖에 없지만 프레디켓이 여러 개 있을 수 있거든요. 예, 그러면 어쨌든 그 프레디켓이 여러 개 있으면 그 모든 것들이 다 true가 되면 이 문장은 다 correct하다 이렇게 말을 하는 거예요. Yeah, let's consider that P is real. So what happens? 우리가 B가 만약에 let's consider B is real. 자, B가 만약에 real이다라고 하면 어떻게 되느냐? So if we follow the semantic rule, it should be this is a real int. So the actual type becomes int. This is int. Actual type becomes int. This is int. Therefore, expected type should be int. B is real, so the variable 3 that actual type becomes real. So if we apply the rule number 2, number 2, integer plus real is real, right? And if we check the predicate, number 2, integer is real. So if we apply this rule, expected type should be same as actual type. So if you apply this predicate, this is false. Yeah. Therefore, this is grammatically incorrect, right? If A is integer, B is integer. So therefore, we can check the type. So if we use this attribute grammar rule, then now we can check the right side is real and left side is integer, or left side is real but right side is integer. Okay. So this is how attribute grammar is used. Okay. So first, we need some what is problem? What we have to check? in semantics. Okay, then for a given semantic problem, we have to describe not only for syntax but also some semantic rules and semantic rule for defining proper attribute, or we have some predicate to check some correctness of its syntax in semantics. And for a given sentence, we can make a partial tree, and by using the semantic rules, we can determine some attribute and how to compute for a given terminal attribute. Then we can compute by following the rules, and every predicate should be true. Otherwise, it is not a correct sentence in this grammar. So as you see, for this very simple example, we have many rules, right? So if we imagine, for example, Java or C, yeah, you can imagine the length of syntax, semantic rules or attribute grammar rules. Okay, so as the size of the size and complexity of attribute grammar is increased, you can imagine the the parse tree and parse tree can be complex and become difficult to compute. So it becomes the increase of compiler's complexity. 그래서 우리가 트리그램마의 사이즈가 당연히 커지면 커질수록 컴파일러를 만드는 사람 입장에서도 그게 점점 커진다. 뭐 이렇게 생각하시면 되겠습니다.